Welcome to a new episode here in the Energy Bridge. And wow, we were talking before recording hard tech for carbon capture and everything. And we're really looking forward for this interview. We're going to dive deep into direct air capture related with carbon capture. So everything what is around with an expert, Gerhard. Thank you for coming today.
Thank you very much for having me. It's a pleasure. Thanks.
Thank you, Gerhard. First of all, we have a lot of introductory thing that we wrote about you, but it's always good to hear from the man himself. Please tell us about yourself and also your journey so far.
Yeah, so initially I've been studying mechanical engineering at TU Wien, focusing then in my master's on energy technologies, so renewable energy especially. And in one of my lectures, I got aware of carbon capture, and there has been an opportunity to go for a master thesis abroad to Gothenburg, to Chalmers University. So I went to the chemical energy engineering department then. Professor Pröll was heading this research group who was working on carbon capture back then. And then, this collaboration started. I got the chance to make my master's there in 2010 or so in Chalmers. So this is where I started to work on carbon capture, actually. And it was
in France, or where
that's
is it?
in Gothenburg in Sweden.
In Sweden.
Yeah, the subject really kind of was so interesting to me. So I was pushing for also the opportunity to have a PhD thesis, continue my studies in this field here in Vienna. And there was luckily there was one project popping up back then with a big oil company, Shell, who were asking the question whether we can make the benchmark carbon capture process more efficiently. I mean scrubbing, which is a process that has been around since the 1930s. So that's quite a challenge, right? So it was very interesting. And the main idea was to switch from these liquid solvents to solid solvents. And so that was kind of the idea. So there was a process idea around that. And this is where I started with my PhD. And then, this took me then, I don't know, from starting with that, building the first lab unit, then my now co-founder and good friend Johannes Fuchs, who also studied with me, came to the research group and helped me with the work there. Yeah, we were building our own lab units there, delivering the proof of concept, and this project got bigger and bigger. And then ultimately there was a chance to stay at the university and really build up my own research group there for another 5 or 6 years. I spent then there working on carbon capture projects.
So you were working in a lab. What was the eureka moment, like the aha moment that you said, okay, we can move from the lab to found a spin-off and a company out of it?
So I didn't directly went from because that was point source capture, right, that we developed with Shell. And we were quite successful with that. So we went really from a process idea when I started with my PhD up to the point where we demonstrated the process in an industrial environment here in Vienna. The project was called Vienna Green CO2 at pilot scale. And we were running this unit for 1,000 hours of operation. And the unit was then also relocated by Shell to the Netherlands. So this was really a successful project. And one thing I realized there was, because actually my plan always was from starting with my PhD to also pursue academic career more. So I was really interested in that. But then, in this execution of this project, I saw, okay, there's so much more that you would need to do after you have your proof of concept, after you started with studying this process, even at pilot scale, right? And there's so many things that are still need to be discovered, innovative steps that need to be taken in order to really make this thing into a viable product. And this was something that I'm also impact driven kind of, right? So it's not really, I don't see so much value for myself in, just finding something out, publishing it, and that's about it. because naturally, I mean, if you find someone who is also interested in the subject, maybe he will read it and maybe get a citation or so.
And then stored in a library.
Yeah, sometimes I think so. I mean, at least, yeah, I discovered this myself several times because we were doing things and we went to conferences, and then there was this old professor, Coryphe from, I don't know, somewhere, and said, yeah, really good job. We did that 30 years ago. So, I mean, it's really interesting. And I mean, finding something out, going into depth into something. This is something that I really took from my days and years at TU Wien. This is something that I still carry around today and that I use a lot, is to you know, if you have a problem, something that someone never has thought about how to solve it, how to come to a solution. This is something that you really do every day at the university if you have a good environment, right? And then definitely is something that I can benefit from. But only academic work was, at least for me, it was not enough. So then I moved on to the industry, spent 2 years in operations of in the biggest waste incineration site here in Vienna. No, that's the most famous one.
Okay.
But the biggest one is Simmeringer Heide. So that's when you take the motorway down to the airport. That's the first. I always used to say that's the first time you start to smell something weird. That's Simmeringer Heide. The second one would be the refinery, right? So that's the location. So it's as a process engineer, is kind of heaven, because you have fluidized bed, waste incineration, rotary kiln, waste incineration. You have the sludge is also incinerated there. So it's a really, really great place to be if you're interested in these kind of facilities.
What is cool?
Yeah. And
so you said it's also a sewage treatment plant there.
The sewage treatment plant is there, exactly, and also the sewage sludge that is then produced comes out of the treatment facility is incinerated there in fluidized bed units. Yeah,
you spent some time also in Diefenbacher.
Exactly. So that Diefenbacher, or formerly known as Berg Energy, was one of the project. It was the plant manufacturer in this pilot program that we had at TU Wien, Vienna Green CO2, and they built this pilot unit. So I got some good connections to those people as well. They were approaching me and saying, okay, we need someone. We want to step into new products. We want to enlarge our product portfolio, and they wanted to develop dual fluidized bed gasification systems. That's actually the main process that got out of the Institute of Chemical Engineering from the research group from Professor Hofbauer, who used to be my PhD supervisor and boss at TU Wien. And so that's why he kind of approached me, because we knew each other. And then I took on this responsibility at Diefenbacher Energy. So 2 years of senior process engineer, especially focusing on product development. Yeah.
You just mentioned technology that I'm not related to, so maybe you could explain it briefly. What is fluidized bed system?
Fluidized bed. I always say that everyone knows fluidized bed units. So if you think of the lottery machine, you have these balls that come into this mixing thing. You know what I'm talking about? Yeah. And then the air is flowing from the bottom into this system, and then all the balls are starting to move around. That's actually a fluidized bed unit. It's that simple. So what actually happens is, if you imagine like a bed of sand, you pull it into a container, and the container in the bottom has like something that we call a gas distributor. So we can introduce gas into that bed. And then what happens is there will be a force from the gas dragged onto these particles. And if you increase the velocity, then this force increases. And at a certain point, the force is just big enough to carry the whole material. And then this bed starts to act like a liquid. So it's really, if you then have this reactor, if you would tilt it, the surface would more or less remain the same, like this, right? So it behaves really like a liquid, even though it's solid particles. And this comes with various advantages. So in process engineering, you can utilize that. So also this point source capture process was based on fluidized beds, and so that was really the core background that we had in this project.
Clearly, you're a researcher, and now you're getting into real industrial asset. But working for your own company, looking into also the P&L and looking into how the company has to scale, and you're a researcher yourself, your perspective of innovation has changed. You think that the innovation is something that can be scaled industrially or in the real life, or how do you perceive it now?
Of course, you would not typically start like in an industrial environment, typically, unless you are a big company and you have the money available with basic research, right? So the POC and maybe first lab tests and maybe pilot plants, that should happen there most likely. But at a certain point, again, there's so much more that you would need to do. For example, in my role at Diefenbach Energy, I was working on gasification processes. So basically transferring waste or biomass or waste streams like plastics or so first into a gas, and then this gas can later be converted into a valuable product like a mixed alcohol or a base chemical or methane or whatever, you name it. Okay. So this core process, the gasification process, for example, that has been researched. That was like the main thing my professor was working on, Professor Hofbauer, for like decades, right? There have been, I don't know, he always tells me the number, I forget it, but let's say 100, above 100, way above 100 sorry, Herman, but I don't know the number. It's so many PhD theses have been going through his hands, right, around this subject. And so there's enormous knowledge. But still, the things that, why these commercial plants that have been built, why that did not work so well is mostly around the core process, right? So the peripheral parts, like how you cool your product gas that you produce, how you extract ash streams, how you introduce fuel streams and things like this. And there's, I mean, especially at Diefenbach, I learned so much, and that was really interesting. And it was also very innovative. So it was not so different from what we were doing at the university. It was just not so much around the core process itself anymore, right? Also, it's one thing to deliver a proof of concept in a rather regulated setting in a lab, but it's definitely way more challenging to have real life operations, daily operations, and reliable relations.
And you have goals that you have.
Yeah, exactly. So,
and we go into the other part of the hard climate tech company, but if you can also explain, because it was very interesting when you were telling us about the fluid bed.
Yeah.
If you can also explain DAC.
In principle, there are different approaches, but the one that we are focusing on is something where we have a filter material. You can think of these. Do you know these sacklets that are packed with electronics sometimes? Have you opened those? They're like these transparent small balls in it that absorb the water that is within it.
Yeah.
So these silica balls
in the shoes or something.
Exactly. You always have that, or sometimes it's packed exactly with shoes or something. So it looks pretty much like this. Color's a bit different, but anyways. But that's the basis. That's commercially available, and these materials, they are functional groups on their surface. And these groups have the ability to selectively absorb or capture or react with CO2 that is in their surrounding, even if it's as low concentrated as in the air. So it's also, I think, used in, for example, in space vessels or so. So they also exhale CO2, the astronauts, right? And this CO2 needs to be captured. And these kind of materials are actually used for this purpose.
For closed environments. Yeah,
exactly.
They have to clean somehow.
And or a submarine or something like this. And so this is the basis. And this material, you can imagine that this has distinct sites on the surface that can capture the CO2. And the amount of CO2 that they can take up is in principle dependent on temperature. So the lower the temperature, the more sites are available, or the more CO2 you can bind. The higher the temperature, the less. And also, if you think of the material and CO2 flying around the material, if there is a lot of pressure kind of pushing towards the material, so if the pressure is high, there's also more binding affinity or capacity than when you have vacuum, for example, applied. And this is the basic principle is temperature vacuum swing adsorption. So you have this system where you have this material, you pass over air over this material, and it captures CO2. And then when it's loaded, you need to heat it up again to a higher temperature. You apply vacuum, and then it releases the CO2 again. That's the fundamental principle of it. It's the same for amine scrubbing, as I mentioned before, for post-combustion CO2 capture. And it was exactly the same that we have had in use for our point source capture system that we developed with Shell. So we know this material very well for like 15 years almost now.
And how is the the lifespan of this material? How long can you use it?
It's a very important aspect, obviously, of the process. The sorbent lifetime, and some of the very first movers in the DAC realm actually had this as a bottleneck in their process setups, that they really degraded the material after like 3 or 6 months of operation. So that's obviously not something that is reliable and viable commercially. And here again, all the experience we gathered over the many years we were working on the point source capture part with the exactly same material. Working together with Shell, we had the opportunity to really study in detail what are the main drivers for these degradation processes that happen. What are the main operating conditions that you need to avoid in your process in order to also avoid the degradation to make it happen or to happen. So our DAC process, apart from the fact that we also apply a different system to bring the energy down, also has incorporated this thinking to avoid these conditions so that we can have a longer lifetime. And the short answer to your question is that we at least calculate with 3 to 4 years. But the problem is we run our units now for only a couple of months. So we really cannot prove this. I mean, you cannot measure any degradation because it's really so low. And if you avoid these conditions, that you cannot really detect it.
Yeah, and is it a rare material or is common?
So our basic engineering thinking is that we use things that are there already in order to be able to scale fast, right? So what we did is we had the material at hand. It's not optimized for DAC. It's actually used for wastewater treatment typically, but it works, right? And it works good enough, and it's commercially available. So there are companies, more companies than one. Also, that is important, where you can buy these kind of materials.
So it's available and it's commercially.
It's available. And we actually, what I wanted to say is we built the process around this material. That's why I got lost. Others really, if you look at like pioneers also in this field of DAC, they really want to focus on their own particle development. They really want to keep the process as simple as possible, and they want to develop the perfect material perfect material for different environments or so where they can operate it.
No, but it's new and novel technology, so it's...
But now just diving deep into DACworx. So you formed your it's a spin-off, right? It's a spin-off from TU Wien.
Yes, there was one investor from Silicon Valley. His name is Peter Rallen, who was trying to search for partners to bring or to develop new technology that can deliver carbon dioxide removal at competitive costs. He has a really great network in the US, right, with all the big names, universities. But something he keeps trying to say is that he could not find someone who could also, translate their lab learnings and basic core principles, process ideas into reality. So he expanded his search, and then eventually he came across this Vienna Green CO2 project. And there he said, okay, there was a group really working with an industry partner and starting with an idea. And they were able to bring it up to the point where we demonstrated it at pilot scale. So maybe I should talk to them. And that's what he did. And then, like in the very first discussions, I was also involved together with Professor Hofbauer again and my co-founder Johannes Fuchs. And then Hermann then drafted this, this project proposal where he said, okay, we would need to do some tests with the material, and then we do this and that, and in year 3 or so we do this prototype, and then let's see where we get from there. And he said, that's a good idea, but let's flip it, right? Build your prototype, and then this is how the collaboration started, kind of, right? Then 2 years of work in this pace, because he was really like pushing us or them. I was not so much involved in the very beginning, but my co-founder was, and they built one prototype after the other, and one process innovation of the led to the next one, and then they came to a system where they said, okay, this is something that we should work on more, and that we consider that can scale this process up.
I mean, it might help a lot if they reach you, like, we want to invest in your research. It's great. And why? I mean, they are coming from Silicon Valley. I mean, the cradle of all innovation. What was your motivation to found the company here in Europe and not in US?
I mean, I would not dare to say that I'm aware of how the environment really looks like in Silicon Valley. I've been there once for an event that we got invited to from our investor, but I think the focus there is more like on asset light things, software. I mean, that's the impression that I got.
But
when it comes to right?
In terms of also the hard technology, not just Silicon Valley, but US as a whole, to push the technology. Did they try to get you to US, or they were fine with you moving in Austria?
The environment that we have here is quite nice, because also as we have TU Wien, and we have good relations with TU Wien. We can use their labs, or we collaborate with them. We also have our own production facilities already here in Vienna through the second company that my co-founder owns. So what we built our prototypes here as well. If you do all this prototyping and scaling, and if you have everything in one hand, and if you don't need to, produce those documents and then get someone to build you the stuff and then get someone to operate the stuff, if everything comes together, and this is really what we have here, then you can move fast. And that is, I think, what was the main benefit. For the deployment itself, I mean, it used to be the case for the former administration, at least, that DAC had very good exploitation or deployment environment in the US. You had tax credits there. You had these DOE fundings for the big DAC hubs, etc. So there was, of course, everyone was kind of inclined. Also, ClimeWorks is one of the biggest players. They tried or they already had been awarded for a bigger project there. The new administration seems to have different approaches when it comes to these kind of technologies, and so all of these things stopped, right? And if you compare to what is going on now in Europe, and maybe we can touch upon that later also, a lot of good things happen here that could be catalyzing also market developments here in Europe.
Yes, nice. Yeah. And now that you work also in the incineration plant, so working with utilities, like having the industrial language, how much that have helped you to try now to sell them the solution?
This is now at the point where we are now. This is really coming more and more into the focus, obviously, for us, because up to last year at least, it was more like on really still demonstrating the process, building a pilot unit. Now we have since last year we have a kind of a first product in operation at our site. It's a downscaled version of our commercial product, but it has the architecture of our commercial product, right? And we run it, and now it's really about getting project partners and then clients to work with us this year or next year to really demonstrate our technology at larger scale. And there, obviously, it helped a lot to also in the designing process of our product, and we're still doing that every day, to think of the operators, right? Really have the glasses of the operators on and think of all. They don't care really what the process is doing, right? They want to have CO2 captured at the lowest costs, and that's the ultimate figure that they're looking for. They don't want to have huge efforts with maintenance. They want to have it reliably. They want to have all these things, right? And I think if you were working for spend some time in operations, it helps a lot.
Getting into that more, DACworx, you target almost 30% lower energy than the current benchmark.
Yeah.
What exactly is the other DAC technologies are doing that is compromising the energy efficiency, and how are you doing it that you're able to benchmark that at 30% lower?
Last year we found out it's closer to 50 to 60% lower. But anyways, the fundamental part of the process is that you need to heat up the material after it's being loaded, right? This filter material, so it take up CO2 from the ambient air, which has, today it's a nice weather, let's say 10 degrees centigrade, and then you need it to heat it up to, let's say 70, 80 degrees centigrade or so in order to release it again. The first generation systems, they wanted to do this, both of these steps in one compartment, in one single reactor. It's like it's like having one room being operated as fridge and as an oven alternating. So this is really intuitively that this tells you already that this must come with some parasitic energy load. And this parasitic energy load is actually substantial. It also comes with a lot of operational challenges. This is why we thought, and this is again coming back from the experience we had with the former projects on post-combustion capture, that we separate those zones. So the part where we take up the CO2, the adsorption it's called, and the part where we regenerate the filter material again into two different zones. And the price for this is that you need to move the material between those zones, which is something that we kind of, we did that in the past in the post-combustion step, because this also had separated locations, and it's something as a fluidization engineer you're trained to do. So this is how to move that in order to also maintain the integrity of the material, and how to do it energy efficiently, etc., etc. There are a lot of more innovations, especially in the regeneration part, where we save a lot of energy. But the core part is really the separation of those two zones.
And do you have any technology, or when you benchmark with the industry right now, currently in Europe, are you novel, or they're already existing? They're already existing companies for sure. In your phase, you're still in a, let's call it a startup phase, and in your first pilots, are there companies which are in more advanced stage, or what is the ecosystem around it?
Yeah, so for the same process that we use, there's obviously Climeworks, I've mentioned the name already, who's pioneering this. And it's also important that someone is pioneering this, because you can also learn maybe from some of their mistakes that they take.
Yeah.
And they do a lot of work, most likely also into developing these markets that are required. TRL level wise, if you want to put it this way, we're certainly at 7 or so. So this means we demonstrated in a real kind of environment. So which is, you just need to place your DAC system out into the ambient air. So between 6 and 7, I would say, is the technology readiness level, and we really want to push it to 8 and beyond that now with this demonstration plant, with this reference project that we are trying to do and land this year.
Nice. And also, we were seeing that your solution for direct air capture, it can be used also together with district heating.
Yeah.
Kind of. So how does it work, this symbiosis?
Basically, there are different energy inputs into our system. Obviously, I said you need to pass air over the filter material. This requires blowers to move the air.
So electrical.
That's electrical
power.
Energy. You need we have vacuum in our regeneration, so that needs vacuum pumps to drain gas and to produce the vacuum, that's again electrical energy. But the main part, about roughly 80% of the total energy that you need to introduce into our system, is heat to produce steam that we use in our system for the regeneration part, for heating of our material and for
to release the CO2.
To release the CO2, exactly. And this steam it's vacuum steam, because we run the regeneration at vacuum, so it can be produced at temperatures as low as 70 degrees centigrade, for example, or maybe 80. And this means that the heat that you need to supply in order to produce that steam could have temperatures as low as 90 degrees centigrade, or even lower if you design for it. And this could be very well integrated with district heat systems, for example, or with industrial processes that have waste heat streams available at these temperature levels. And there are a lot of these processes actually that produce this kind of waste heat. Question is always whether you can integrate really, because no one will operate their processes in order to keep our tech machines running. But this is certainly something that we look into, and we have a research project going on currently with TU Wien and your name research. It's called Advance, and there we look at the potentials here in Austria especially, and how they are. And I think Vienna has actually quite good conditions.
Heat infrastructure, yeah.
Yes.
So you capture the carbon with this material, then you heat it up to release it, then you store it, right, in a gas version. So what do you do with the CO2 after? And what are the products?
Just one question in between. Before that, you were saying that you started in Vienna. What is the potential? Like, how many industrial sites which are already they have the potential to be DAC ready, if we may call it?
I mean, DAC ready is, I think, what you said is the more critical part currently with regards to being DAC ready, and that is what are you doing with the CO2, right? From my perspective, and that here in Austria, I mean, we have actually decided on a governmental level that we want to, because it's still legally forbidden, right, to store CO2 underground unless you do it for research purposes. But it's actually the government said, okay, we need to get rid of this and we need to allow for underground storage, CO2 storage, in order to be able to keep track on our climate goals, right? So for hard to abate emissions like waste incineration plants, like cement plants, so the bigger emitters, we need that. But we also need a lot of CDR to happen, right? Technical CDR, so technical carbon dioxide removal, in order to stick to our climate plans. We were involved in the elaboration of the carbon management strategy, and I think the range was something between 1, if I'm not mistaken, but it's 1.57 or so to 7 megatons of CO2 being captured annually. So that's from the atmosphere, removed from the atmosphere, in order to be climate neutral in 2050, already by 2040. So this is a lot of CO2, right? So if you compare that to the total emissions, which is 70 megatons something, it's less now, but something in that range. So 65 to 70 roughly. So it's up to 10% of that we emit currently, we need to capture from the atmosphere.
Yeah, because it could be used for synthetic fuels. Also, we have a friend who is storing CO2 in materials.
Yeah.
For construction, or
Lucas Höber from Signes.
Yes,
right?
Lucas from Greetings to Lucas.
Yes, yeah, that would be also very interesting to store it in these kind of things. And I also think that utilization of CO2 coming from DAC processes will be
the green CO2.
Green CO2 to feed as a feedstock for synthetic aviation fuels, for example. So there's the Refuel EU Act, Aviation Act, that demands that these synthetic fuels, the addition of these kind of synthetic fuels to the aviation fuels that we use currently in Europe, needs to increase significantly over the next 1 or 2 decades. And so this triggers a lot of renewable or sustainable CO2 demand. And this cannot come only from biomass, in my point of view, because there's always a competition, right? I mean, if you, for example, BECCS and DACs, if this comparison is always on the table. So if you look at the demand of like footprint demand of a capture unit, the DAC capture unit for, let's say, a capacity of 1,000 tons per annum, that will be roughly fit into this room, right? That's the footprint of this unit that we're talking about. And now imagine how much trees you would need to grow over a year to capture, like what the size of so that's accordingly, I mean, maybe that's not 100% correct for every sort of trees, but it's closer to 1 square kilometer, right? Wow. So that's a huge difference, right? Alone from the footprint wise, right? I'm not a big fan of bashing the other against another technology, because we will need everything. Technology that's available, right? And but yeah, DAC will also need to supply this demand when it comes to the sustainable aviation fuels. And I also see the market to be around earlier than the real big markets for carbon dioxide removal.
I think we should move forward to CE region because it's the region with the highest emission, maybe because of the gas dependency, carbon available source to burn and generate. So how do you see the potential of the region, and which conditions have to be there to implement these kind of solutions?
One thing I need to be clear on, I want to be very clear on, is that DAC cannot be an excuse for emitting.
No, right? For sure. So
you need to do everything you can do on the decarbonization pathways that we all want to see happen in order to bring down the emissions, right? Then it's about residual emissions that you need to compensate still, and then also legacy emissions, right? Because we might not, we're not on the track for the 1.5 or the maybe not even the 2 degrade. So this is like a clear motivation everywhere to do carbon dioxide removal. Also, what I would argue, though, is that maybe it can also, like in a transition. So I don't think that, because it's also an export heavy kind of region, right? A lot of manufacturing is going on in the East, which is also something that we would like to benefit from, because it's a bit cheaper to produce there as compared to here in Austria, obviously. And so in order to bring down the footprint of the products that are exported from this region, I think maybe it's more economically feasible and viable to do that via carbon dioxide removal somewhere where it's suitable. Then, I mean, I don't know if we would have all the green steel available at the time we need it in order to bring down the footprint of these products as well. So maybe this is an angle that I would see for this region. But when it comes to compensating for natural gas use, or so for energy production, electricity production, for example, or for heating.
Or hard to abate industries.
For hard to abate, as I mentioned, like cement plants and waste incineration plants, for example, they would need, most likely, because technologically wise, there's not much room to do. So you need to capture whatever is emitted there. You can also not capture 100% of what is emitted there, because that is also not economically viable, right? So
how much can you capture?
Yeah, from flue gas, typically what you have in points as capture, it's 90%, right? So
that's good.
But we need to be 0, right? Yeah, but again, DAC is something that also needs to compensate for these residual 10% coming out of the capture plants. So it's not the whole story if you say, okay, I have a post-combustion CO2 capture system there and then everything is fine, it's decarbonized. It's not, never, right? So there will be a lot of residual emissions still also for this.
You can tell the capacity, but the first facility in Europe for DAC, where it would be and what is the capacity?
Yeah, we're still looking for a good project. I mean, there's ideally, because you will learn so much from such a project, right? Not so much on the technological side, because again, our pilot systems that we run now, they really have exactly the same architecture as the commercial plants that we are going to build. So the capacity of this pilot plant is in the area of 100 ton per year. And the scale up will be a factor depending on really also the market, but most likely we'll have a low scaling factor now, 3 to 4 rather than 10, but it will be in the range less than 1,000 tons per annum, most likely for one single standard, DAC standard. And ideally we can demonstrate the operation of this standard somewhere close to Vienna or in Vienna even, because you will learn so much from the operation, right? Also the non-technical stuff, like the
all the supply
processes, the supply chain. So you work together with other contracting companies and with the client, with the utilities and etc. So I think also as a young company, even though we have some experience, obviously from the industry, there will be a lot of things to learn from that perspective. And the closer you are to the project, the better it is. So yeah, having said that would be the ideal thing. We have some more concrete discussions for project developments in Germany, but also through our US partners, outside of Europe. So those are the more concrete projects that we are currently talking about.
And to choose the location, you need proximity to waste heat, grid connection, and buyers, or like CO2.
It depends a bit on the environment. So again, there are basically these two potential deployment pathways. One is the e-fuel part, or the synthetic aviation fuel part. So there are regions like the one that you're initially coming from, where you have conditions, for example, where you have, I don't know, above 7,000 hours of wind, full load wind energy available. So in these regions, you have low electricity prices because you can produce it with wind, for example, and then you can have low cost hydrogen produced. And with this hydrogen, if you have a carbon from any molecule available, you can then synthesize these kind of base chemicals like e-methanol, or there are different synthesis routes, right? I'm not an expert here, but basically all the hydrocarbon products that come out of these synthesis routes, they need carbon and hydrogen. And these regions where you have these renewable energies available, they are also lacking in biomass. Right. So also the Middle East, for example, if you go there, it's biomass is not abundantly available. So you need the carbon to come from somewhere else, and their direct air capture can make a lot of sense. Right. Other route would be storage. So really, if there are some clients around the world that really try to set up these projects where they can also sell the credits for storing CO2 that was harvested from the air, so net CO2 removal from the air, and sell the credits. And there obviously you need these kind of project locations where they have a storage site.
And this 1,000 ton facility, is it going to, I mean, I don't know about the size, like how big is it? Is it a small facility? Is it a big? And would you rather build smaller ones, or if you go into like Middle Eastern market where there's really absolute need for it as well, and make a mega one?
That's a very good question, and a question that we were heavily discussing over the last few months. So my perspective here is that first you need to look at the basic techno-economics of our system. And if you look at it, and we did that for one certain project in Africa that we tried to do last year, we came up with roughly 70% of our CO2 costs that for our DAC system come from CAPEX, right? So bringing down, we really, process-wise, we really kind of solve, even though like in the public debate, it's when you talk about, or you read something about DAC, everyone is talking about the energy. I think process-wise, I mean, there's a lot of room for improvement still, new adsorbent material, etc. But we solved that part, right? Now it's really about the CAPEX, and there's a huge potential to bring that down, because we were calculating these numbers still for considering self-production here in Austria. So if you go to other places like in the Eastern Europe, for example, produce there, if you then especially go for standardization and modularization, where you can have pre-assembled assembled modules being shipped to the site and less project site activities, etc., then you can substantially bring down the capex. Engineering costs go down, etc., etc. So this is what we are trying to do. And then the question is the unit big? Is not so much. The real question is, you can have individual modules, like think of a Lego part, right? You can build big, I don't know if you've been to Lego World or Lego House or so.
Crazy. Yeah.
Huge things you can build with these small bricks, right? Because it's modular, right? So it doesn't necessarily mean that if you do modularization that you can't build big, right? Still have your standardized modules. Where the cost optimum lies, I don't know. I mean, there are people saying smaller units, completely pre-assembled, ship it there and just erect it, and then, there are a lot of benefits coming from that. So, and the first units that we might want to build are exactly this. So you have completely prefabricated, pre-assembled, pre-tested also DAC standards that go to the client side, and then you just need a crane, put it there, bolt it down to the foundations, and then connect it to the utilities, and then it's operational. So this is what we are in the first step are going to. So, and then the costs come down by simply ordering multiple
volume
of these volume. Yeah.
So since we have you here, we have to go to policy wise. So in general, how do you see the European policy for air capture, carbon capture in general?
Yeah.
What is your vision about it?
As I mentioned, we got the chance to be involved in the Austrian carbon management strategy with regards to the working group that was working on carbon dioxide removal, and through that we also had a better view on that. I'm not a policymaker, so I'm not completely aware of everything, but in general, what is really great is now that we have the CRCF, the carbon removal certification framework, available in Europe, which basically gives you the guidelines. It's a playbook for how this carbon credit market will work, how the quality checks will be, who is going to certify, and who can sell them, and how you can buy them. So kind of this is how you also calculate the net removals for every technology that you can apply.
To standardize the process, how to measure how much are you capturing.
So what is like how do you calculate the carbon footprint of your energy supply? For example, waste heat, we were discussing this before. So waste heat is considered as carbon neutral. If it has not been utilized before, then this will be considered as carbon neutral energy input into your DAC system, which will increase the net removal rate from your system. And so this is great. So this framework is around. Also the Refuel EU Aviation Act, right, also gives a great pull effect, because there's a market, right, that is going to be around where we have a need for sustainable carbon. And also and I think this is really required some sort of catalytic mechanisms like public procurement measures. I think in Germany they were announcing something like this. In Denmark they have it. And also there's a European Buyers Club that is being discussed, who is, because you first projects, it's really about risk mitigation, and financially it's really hard to mitigate that really unless you have equity financing in the back, or if you have fundings or public procurement programs, for example. So I think this will be essential. And where we also move a lot forward is on the storage side. I mean, we have Northern Lights now being in operation, I think in Denmark and the Netherlands. There are storage projects being developed. Yeah, for Austria, for example, this is, nice, but it's still far away. So of course, CO2 transport infrastructure. So everything around that also needs to kind of be pushed. But in general, there's a lot of things going on in Europe. And I think if we now really take the chance to see all the challenges that are popping up around us, if we take this as a chance to really go for scaling this kind of technologies in Europe, then we can be very successful with this kind of things, also export-wise, I think, in the future.
You have the institutional investor already on board, But what is the hardest slide that you might have to go through if you're in touch with other institutional investors as well, to make them understand if it's that it's a bankable project?
We really try to be stick to what we know and what we can when we present anything to also to our clients, right? Because I think so many promises, especially around tech, being given in the past, where we say, okay, we have a good product, we have a good process, and we should not dare to be too over optimistic. Also, when it comes to what are the projected costs and etc. And this is then really the question. So, is there a business case ultimately? And I think if you look at the numbers that we have, the techno-economic assessments, the early ones that we did, and the discussions we had with project developers, not so much in Europe, but outside of Europe, that want to produce e-fuels, for example. I mean, they have a business case when we deploy our DAC machines to them that would fly for them, right? Here in Europe, I think, again, buyers, clubs, and maybe some public procurement programs, something like this, maybe some investment subsidies for very early demonstration projects could help to really bring the risks down of being bankable, and then really, kick start these markets.
And how do you see like being in the future 2030 ecosystem for carbon in general? How do you see it, and which policy framework would you promote to foster this technology?
Could be a whole podcast. I mean, I'm not an expert there.
We can do another, but just short answer.
Short and yeah, I think if you look at the ETS, for example, the compliance market, it has been very successful, right? So I think I'm not sure if all the emission reductions we see in Europe really can exactly be, related to the ETS alone, but there have been substantial reductions being, catalyzed by this system. So compliance markets seem to work, and why shouldn't it work for CDR as well?
So ETS is emission trade.
Yeah, exactly. So the emission trading system that we have here in Europe. I mean, this makes it bankable because there's really a demand then, right? And how to structure it and etc. And there are discussions actually if and how we can incorporate CDR also into this market, right? In order to have a compliance market for this. And because the VCM, so the voluntary carbon market that is around, if you look at it, it's still dominantly, I mean, there's one single buyer dominating, and that is Microsoft. I think last year it was, again, something 70-80%, if I'm not mistaken, of all the credits that have been bought have been, or credits or pre-purchase orders or so have been bought by Microsoft. And there are new buyers coming in to the game, but I mean, this can catalyze early projects. Mm-hmm. So if you sell it at high prices, that can help a lot. And this is also what I think those big companies want to drive, that, the projects can be realized economically, the very first ones. But then it needs to go most likely into a more compliance market.
But in general, what do you think about the carbon market? You touched upon briefly currently. The carbon credits and the carbon market, so you think it's evolving in a good way within Europe?
The most recent things that I've heard,
and also and the role of DAC in this whole ecosystem.
So in the ETS market, it doesn't have a role currently, but the voluntary carbon market, if you look at this, you also see some consolidation going on. So I think early on there were the market prices were very high. So the first time I looked at CDR.FYI, I think it was more like on 700-ish or so dollars per ton, where the average DAC ton of carbon was sold. And now I think it's moving more towards the 400 range, and 2030, I think it's still expected to be, the best buyers will be somewhere in 350 euros per ton or so, which is for us still in a range where we say, okay, even the early projects could make a lot of sense from an economic perspective. Ultimately, everyone thinks that we can only bear credits to be as expensive as, I don't know, 100 euros a ton or so, for example, when it comes to CDR credits.
Mm-hmm.
And on the long line, 2050, I think it's not impossible, but who knows? Yeah. But certainly, so again, we want to stay realistic and conservative with the promises we make.
Mm-hmm.
And for 2030, our approach is really, our goal is to have our first commercial projects develop CO2 capture costs at around 250 euros per ton.
Amazing. I think it's been very insightful, but there are so many topics that we want to go further and make like another podcast with you. But coming to the last round, as we call it, a quick fire round.
Yeah.
This is a technology which requires money, but let's say hypothetically you have 1 billion euros. What would you put that into to accelerate energy transition?
In general, or for DAC?
Yeah, in general, or if for DAC, yeah.
Yeah, for DAC, I think it would be. I always say, I mean, in order to have something being bankable, you need to have a reference project. So, and this comes with a lot of risk. So I would kind of de-risk financially such a project to have the reference project being delivered.
What would you say that is the more persistent myth in carbon capture?
What I always get is the question, why don't you capture it from a flue gas? Why do you capture CO2 from the air? And this is kind of that's like in Austria we say that's like comparing Äpfel mit Birnen. So something that is not really the same. It looks the same because it's CO2, but it's not the same, right? It's like if you think of a bathtub and you fill it up with water. So the edge at the top of the bathtub is really what we can allow to have carbon inside our atmosphere. And what carbon capture does is really it chokes a bit the amount of water that goes into. So it limits the amount of water that still goes in. But it still increases the level. So you need something to pull it out again. And this is what DAC is doing, right? We pull out the water, we pull out the CO2 again. So we need also technical solutions for that. Nature-based solutions are not enough. So this is really
nice all together at the end.
All together, ultimately, yeah. But the confusion is a bit different.
Yeah, why from the air? Okay.
Yeah, and of course it's a bit of more of an effort to capture it from a diluted air stream than from a concentrated stream. But energy-wise, we were not far away from what even the point source captured guys are doing.
It's a question that we ask everyone, but who have worked in different ecosystems. You lived in Gothenburg and Sweden for hard tech is also. I think it has good ecosystem within Europe. From Vienna or from Gothenburg, where were you challenged more, or where you think that more conducive environment for a hard tech sector?
Yeah, well, I mean, that's like 15 years ago or so, or 16 now. And I was like spending my time on the university. So I can maybe just comment on the universities. And obviously there are differences. So the way they cooperate also at the university, I would have wished these kind of collaborations with, between different disciplines to be more, pronounced also here in or developed here in Vienna. But also what I saw that here in Vienna we also have like a more drive towards the actual application, and that it so being more applied in terms of what our research is the outcome is that we are targeting. So challenging, I don't know, different environments. I loved it there. So Gothenburg is a really nice city. I spent most of the time in winter times there, so I don't recommend that. Oh. It's better to be there at summer times. But also Vienna is a very beautiful city.
Yeah, it's beautiful. We always say in every episode. So
I was also there in Gothenburg in not exactly summer, but sometime in September, but it was super cool city.
It's really nice.
Okay, so since you are coming from the academy research, which advice would you give to researchers in general to be brave enough to start a company out of it?
For me, it felt rather natural, right? Because when I was spending my time at university, there was simply not the environment there to really do something bigger commercially, right? Because that's not the purpose of the university. When I was at the company level, it was simply not flexible enough to also bring in like all the ideas that I had, all the improvements that I saw in whatever processes I was working on. So the flexibility was no longer there that I had before in academia. And now as in a startup, you kind of can combine both. So if you're interested in really doing things, it pays off, right? Because only in that situation, if you have some people that trust you, of course, and you get the money that you need to do that also. But if you have that passion, then you also will not have a hard time to find someone who can back your ambitions, I think, and then do it, because it's especially when you're young, because what is there to lose, right? You can only gain so much from that. And this is also something, the spirit, when you talk to our investor and like the people in the US, it's way different to what we have here.
Especially
I think it's growing
in Austria and also in Europe. What's there to lose? Because people also get unemployment money.
Yeah, yes.
Just
In
right.
this case, it's really, so there's nothing to lose when you're young, right? I mean, for me, it was a bit, I had my kids and some interest rates to be paid for my apartment, I think. So, but when you're young and you just graduated and you don't have that, then shoot for it, because you will learn so much. I mean, I also learned a lot in the industries, in the companies I was working on. But if you really have the idea and you really want to push it to a certain level, the best thing you can do is you found your own company and then try it.
Yeah, nice. Yeah, thank you, Gerhard. Now I know more about direct air capture. So thank you very much. For sure, we're going to hear from you soon. You're going to be part of our forum in June, 2nd and 3rd of June. Yeah, it's a topic that it's ongoing. We are happy to connect you also with more people in the ecosystem that they could use your CO2, for example. So yeah, very grateful for having you.
Thank you again for
Thank you, Gerhard.
It was a pleasure. Thank you very much.
Yeah, and thanks to the community for watching the episode until the end, and keep tuned for a new interview. Ciao, ciao, ciao.
Bye.